Welcome to the debate. Our source material today focuses on some of Earth's most extreme environments. The record-shattering cold of Vostok Station, the scorching heat of Dasht-e-Lut. And these sites are often called terrestrial anomalies.
Right, and that really forces a central question, doesn't it? Are these places genuine anomalies that, challenge our scientific understanding? Or are they just predictable, if staggering, endpoints of known physical laws?
Exactly. And I'll be arguing that their sheer scale and their deviation from the global norm really does necessitate their classification as true exceptions.
And I'm going to argue from the perspective of mechanism. While these places are, of course, extreme, the evidence provides clear scientific explanations. So for me, they aren't breaches of nature, they're actually powerful confirmations of it.
Well, I think these sites are anomalous precisely because they push the environmental boundaries so far beyond ordinary experience. Take Socotra Island. You have millions of years of profound isolation that have resulted in over a third of its species being endemic. That's not just high biodiversity, it represents a fundamental biological exception. It's a deviation so significant you can't just treat it as another data point on some kind of continuum. Or the Darvaze gas crater, the eternal fire. It's been burning for half a century. That is a potent, persistent symbol of nature's volatility, and it certainly exceeds standard expectations.
See, I think the mystery really just dissipates when we look at the physics and the chemistry. You take Lake Hillier's astonishing pink hue. That visual shock is attributed directly to an algae, Dunaliella salina. It produces these high concentrations of carotenoids to protect itself from extreme salinity. That's a known, predictable biological response. Or blood falls, which was initially this great mystery. Well, it's just iron-rich brine oxidizing, rusting when it hits the oxygen. They are rare, yes, but they are scientifically accountable.
Okay, I appreciate the focus on mechanism, I do. But that interpretation risks simplifying the sheer complexity we're observing here. The crucial distinction lies between a known mechanism and a highly anomalous result. How can we just dismiss the scale of the Nika crystal cave? We understand how selenite crystals grow, sure, but growing them to 11 meters long inside a cavern with near 100% humidity and 58 degrees Celsius heat? That requires a set of simultaneous, nonlinear conditions that push the statistical envelope into the realm of a true exception.
I'm just not convinced that extreme rarity or colossal scale equates to a defiance of natural law. The fact that microbes can survive in subglacial Lake Vostok, or that specialized organisms thrive at bloodfalls, is a testament to the comprehensiveness of evolutionary adaptation. They are products of isolation and time, evolving within the known parameters of biology and chemistry to fill whatever niches are available. Nothing about the size of a crystal or the tenacity of a microbe actually breaks the foundational principles of thermodynamics or genetics. It is simply a very long-term expression of those rules.
So let's focus on that then, on rarity and the definition of anomaly. Think about Salar de Uyuni during the rainy season. It transforms into this flawless, infinite mirror, or the more rocky boulders, with their almost unnaturally perfect spherical shapes. These events are so far outside the standard distribution of planetary phenomena that they demand the designation anomaly. Regardless of the formation process, it's the statistical improbability that really matters here.
And while I concede the visual spectacle is breathtaking, statistical improbability still doesn't equal lawbreaking. The fact that Salar de Uyuni sits on top of the world's largest lithium reserve, well, that just confirms known geological processes operating on an immense scale over immense timeframes. We have to maintain some conceptual rigor. These are profound extremes, yes, but if the mechanism is understood, even if the scale is massive, they confirm rather than contradict our understanding of physics.
Then my position remains this. Whether it's the lethal hostility of Naiki Cave or the alien, isolated landscape of Socotra, these sites are potent reminders of just how much deviation Earth's environments can sustain. They represent true physical and biological exceptions to our global norms.
And I would maintain that the material actually demonstrates the comprehensive reach and predictability of natural processes.
Earth's extremes, while they are awe-inspiring, are testaments to the power of established laws operating over millions of years under very specific singular conditions, not evidence that those laws have been superseded.
Ultimately, it seems the debate really does lie in how you define the word anomaly. Is it a technical defiance of the rules, or is it simply a breathtaking, once-in-a-million-year example of the rules being pushed right to their absolute limits? We'll leave you to consider where that line is drawn.